Hey there, welcome back to my channel. Let's continue with our episode. In the previous episode, we have seen how the conditional statement and pointers are working. In this episode, we are going to work on our functions. The functions are an essential component of a programming language. You can say those are fundamental basic building blocks for a programming language, right? So in Go, how we can declare a function? You can see this is the kind of function, right? Which is going to be used like func keyword to declare a function here, right? The func main. So this is a very simple function. We are just performing some operation here, right? So let's declare a very simple function in Go. As an example, func say hello, right? So in this case, this is a very simple function, and this is going to be return something like fmt.println hello J, right? So while we are going to call these functions from here, say hello. So let's try to run this application, right? So Go, right? So can you see it says like hello J. So while we are calling this function, this say hello function, it's not returning anything. It is just saying like hello J. So now let's declare another function. This is going to be like func get username, and here we need to define a kind of type. What type of data we are going to return from this function? This is called, let's say, string, right? So return will be, let's say, my name is J, right? So while we're going to call this one, right, then it should have to return something. So then let's try to call these things here. So let's say fmt.printf, right? So returning from function, this is going to be like default format and get username. So let's try to run this application. Now can you see it is saying like my name is J, so returning from the function. Now you can see both the function. One function is returning something from here, and another one is not returning anything from here, right? So those functions who is not returning anything, those functions are called void functions. So now while we are calling this function, right, get username, it is returning a kind of string here. So it can be anything. Whatever the type you are defining right here, based on that only it will going to be returned, right? So it can be anything. It can be basic type or maybe composite type. As an example, maybe it can be a kind of string, it can be integer, or it can be a kind of array, slice, map, etc., right? So let's try to change this return type from here. Let's say I'm assigning kind of int, and now can you see it is complaining because we are not returning a kind of integer right here, right? This is how it is going to work, right? So let's try to revert it back, right? But this time we are going to declare one more function. Let's say we have not received anything from here, right? So it should have to receive something which is going to work accordingly, right? Based on that, at least we can perform some operation, right? So how we can do that? Let's say func get user by ID, right? So in this case, we need to accept the ID, right? User ID. So let's try to put ID as a first parameter, and second parameter are going to be a kind of type, which is going to be integer, right? We need to return something like this way, as a kind of string, maybe a number. But in Go, you can return multiple types. Just like we can say in the first parameter going to be a string. This is going to be username. Let's say second parameter going to be, let's say, age. All right. So in this case, int. All right. Now let's try to return all this data from here, right? Return first parameter will be J, and second parameter will be, let's say, age will be like 36, right? And here we can call the DB, right? DB call, right? By using that specific ID, right? But here can you see the inside the function parameter, while you are passing something, even if it is not being used also, it is not going to be complained because it's already being gonna be used somewhere. Let's say while you are going to call this function, then you need to pass this value from here, right? So that's why it is not going to be complained. But this is not a kind of good idea if you not going to use anything as a kind of Go paradigm, just to try to remove it, right? But in our case, let's say we are going to call DB call, let's say pay call, right? So in this case, println, right? And ID, let's say. Now it's being used. So while we are going to call this get user function, it is going to return the two parameter, But here is a kind of single parameter. That is why it is going to work something like this way. So printf, it's going to accept only one parameter at this moment. So that's why it is working here. But if we are going to use the similar way, this function, it's not going to work at all, right? So it will going to give some error. Let's try to use this one here and pass by ID this one. Can you see it's not being used? It says like it is returning multiple value, but we are not accepting multiple value right here. So let's try to use it in correct way. So how we can use it? So here, let's say first parameter will be our name and second parameter will be our age, right? Now, because these are the two variables we are declaring here, but those variables are going to be initialized from where? From this function. So let's say get user by ID is 1, right? Now you can see like this age is integer and this name is a kind of string which is coming from here, right? Now let's print it out. fmt.printf and name will be something like this and age will be something like this, right? And name and age, right? Let's print it out here. Now you can see name is J, age is 36. So this is how it's working here. Now you can do much more things right here. Let's say here it's a little bit confusing at this moment. Let's say first parameter can be maybe age also, maybe kind of name also. We are not sure. While you are hovering to this function, can you see it's like simply saying string and integer. That is how we are defining here. Maybe if it can have a maybe it can have a multiple parameters, then how we will define like which one is age, which one is kind of like name. Then you can tag this specific value or parameters right here as a kind of name. Let's say name, and this is going to be, let's say, age, right? So now if you hover to this function right here, then you can see like, first parameter is name, second parameter is age. So this is how it is working. This is really cool. But what if we need to accept a multiple parameter? Let's say we need to fulfill, let's say while we are going to call this db call, we need to find out all the users greater than 16 years of age. Then how we can do that? So let's try to accept a multiple parameter, right? So in this case, let's say age input, right? This is going to be integer. This is very simple, right? So we cannot keep this same name here because already we are using as a kind of identifier here, right? So this is going to be overlap, or it will going to be complaint. So let's try to keep it this way, input, right? Now this age input also is gonna work. We are going to utilize in db. Then it's gonna work. Like you need to pass it right here. Let's say 16, right? Give me all the users greater than 16, let's say. But another way also you can do, rather than declaring this the variables like id int, again age input int, something like this way, just like remove this one from here, right? And go over here, put a comma here right here, and put the age input right there. Then it's still gonna work, right? If you're going to run the application, right, then still it's gonna work. You can see name is J, age is 36. This is how it is working. Cool. But what if you are not sure, like how many numbers of input it will be there? Then how you can do that, right? So let's try to have a look on that as well as. So let's say we're going to declare one more function that is called, let's say, calculate total, right? So now we need to say to Go like, hey, please receive the multiple parameters right here. So in this case, let's say products, and we can say, right, 3 dot and float 64, let's say. And we are returning a kind of float 64 as well, because we need to calculate all the product informations from here, right? In this case, let's declare one more variable that is called total amount, right? This is going to be like 0.0. And now here, return total amount. So it is not complaining anymore. But here we need to perform the calculations. So in this case, we're going to use the for loop, right? For index and let's say price. And this is going to be a range of what? Range of products, right? So inside that loop, we are going to say like total amount plus equal price, right? And this index is no more in use, right? So what you can do, either we need to remove it, or maybe we can just mark it as a kind of underscore, because we don't want to we cannot keep it like one single value here, because while we are deconstructing from here, right, from range, then it is required to, like, there are two parameters. If you go to range, specific range function, you can see, like, while it is going to be give it back, there are two parameters to come back, right? The way we have done right here, name and age, the similar way, right? So now if we're going to utilize this function right here, let's say we are going to say like fmt. So because this function we no need to again assign to some different variable, because it is only returning one single value here, not like this multiple, right? So let's try to use fmt directly. Fmt printf total amount will be, right, then here calculate total, and we can say like 1.2 comma 4.5 comma 4.4 0.4 comma 1.6, let's say. So technically it is accepting a kind of array, which is we are just spreading out something like this way, right? So if you now go and run this application, you should supposed to see the total amount. Can you see total amount is 11.70, right? So this is how it is working. So let's check it out how the anonymous function is working in Go, and the way it is working in other languages as like closures. We are going to declare a variable, and we are going to assign a kind of anonymous function on that. So at least we can perform that specific operations by using anonymous function, right? So in this case, let's say concat username will be fun, right? And here we are providing the name f name, first name, which is going to be a string, and l name, which is going to be a kind of again string, right? And it will return also string, and here return, let's say fmt as printf. Here first parameter will be our first name, and second parameter will be l name, last name. So here also we need to provide the parameter as, right? Now this is first name and last name, and if you're try to print it out, right? So this is how it's gonna work, like fmt printf, let's say user full name is %s, then we can say concat. Here we need to provide the values, right? The value is going to be like first name J, last name, let's say Gogoy, right? So now if we are going to run this application, it should have to return the full name also. Can you see the user full name is Jai Gogoy? Perfect. So now you have seen how the functions are working here. So we can use a kind of void function, as well as we can return it also. We can return multiple values also from the functions, right? We are accepting n numbers of inputs also here, and we can perform certain operation and give it back. Now I am going to clean it up everything, and we are going to move forward to our receiver functions, right? Let's try to remove everything from here. So here in Go, receiver functions are used massively everywhere, right? Even in our application also, we are massively going to use the receiver functions, right? So right before writing some receiver function, we need to understand how receiver function is working. So receiver function is a kind of special type of function, which is only can be performed on certain types or certain things, right? How it can be performed on certain types. So let's try to have a look. Let's try to declare a struct here, which is going to help us to understand the whole receiver concept, right? So in this case, let's say type product and struct, right? So we are going to assign some property. This is called name. Let's say name is a kind of string, and we say price is a kind of plot 64, and stock will be int, right? This is cool. Now this is struct, right? So let's try to declare a kind of receiver function here. So while we are going to declare a receiver function, certainly it's look like a normal function, right? So the similar way we are declaring the normal function, the same way we need to declare. So let's use the func keyword to declare it. And first parameter will be our receiver. The receiver will potentially going to be this struct, right? So P for product, let's say, all right? We are going to use short convention here. Say calculate. This is the name of that specific function, the second part. And third part will be our input, like what exactly we are trying to put the input. So in this case, let's say QTY, right? QTY will be quantity, which is called int, right? And what we will be returning it. Return is a kind of float 64, let's say. All right. So which is we are going to return it. So in this case, let's say we will say return P for price and into float 64, because we need to cast it the quantity with the float 64. If you're going to directly multiply this plot with the quantity, it's not going to do, because it's going to complain, because you cannot directly multiply float 64 with the int, right? You need to convert the float 64 to int or int to float, something like this way. So it has to be the similar data type. Let's try to cast this int to float 64, right? So if we add float 64, this is not going to be correct way, because we need to store the quantity in database as a kind of integer. The quantity cannot be like 1.5. It can be either 1 or maybe 2, something like that way, right? So this is perfectly fine. While we are just calculating the stuff, then it has to work. So let's try to declare a kind of struct here, right? So now we have our receiver function, we have our struct. Let's try to implement that. But before that, let's have a try, like how we can call this one, right? So let's say try to call it. But where's this function? This is gone, right? This is not there. So yeah, this is true, because we cannot call directly a receiver function from anywhere unless we are creating an instance of that specific things. So let's try to create an instance. Let's say product, right? Or maybe you can say like a P also product, right? P, and say product, and we need to give a name, let's say Mac Pro, and the price will be, let's say price will be $9,000, let's say, all right? And stock will be, let's say only one left, let's say. Perfect. So this is our struct. Now let's call this receiver function here. So p dot calculate. Can you see we can directly perform this function right here, right? So calculate how many quantities, let's say 2, right? So we can perform this one. So let's try to print it out. fmt dot printf. This is going to be like total amount will be plot, right? Let's try to put like this way here. Now if we're going to run this application, it's gonna work. It will going to calculate the price. Let's say 18, right? Yeah, 2 times 9 equal to 18, right? It's 18,000. Perfect. So now you understood, right, how this receiver function is working. The receiver function is only applicable while we are creating an instance right here, and while it is receiving a kind of receiver of that specific type, right? So that's why it is able to call it from here only, not from the outside of that specific instance. Perfect. So now you got the idea how this receiver function is working. So let's say now we need to update this stock right here, right? So how we can do that? So this is the similar way it can be possible, right? But not. So let's try to do that. Func, let's say first receiver function is going to be P per product, right? Then let's say update stock, or maybe we can say reduce stock. This is going to be meaningful. Reduce stock. This is going to be quantity, again QTY and int. Then we are not returning anything because we are going to perform some operations right here, right? So let's say if we say p dot stock is greater than equal is quantity, then only we are performing that operation. So p dot stock will be minus equal quantity, right? So this is what we are going to reduce it, right? So now if we make this call, let's say p dot reduce stock, let's say 2 or maybe 1, right? In this case, let's say 1 fmt dot println the product, right? Now let's try to run the application here. So if you are going to run the application, it has to be reduced to the number of the stock right here, right? But it will not. Can you see? It is not updating at all. Why exactly it's not happening, right? So let's try to understand where exactly it's going wrong. If you can have a closer look of this function, right? So here we are not doing anything. We are only just to try to get a calculation of that specific price right here. We don't care about the stock. We are just checking it out, like whether if we wish to buy the 2 items of this one, then how much it will be cost. It is simply like going here by checking the price and giving back the data, right? Here, nothing is going on, okay? But here, we just try to access that specific product, right? Which is a kind of instance of this one, right? And we are trying to update based on this condition. That is perfectly fine, but it is not updating. Because while we are calling something in Go and passing some parameters right there, then it is not calling by reference. It is calling by value only. So that's why it is not updating at all, right? Because this P is assuming it's a kind of value, not a kind of reference at all. But how we can keep a kind of reference? So in that case, you just mark it as a kind of pointer right here, right? This is also going to be a pointer, right? So now if we're going to call this function, then certainly it's going to decrease to the stock. Can you see? Now it is gone, right? So this is how exactly reference is working, right? Perfect. So I hope you got a clear understanding of how this receiver concept is working. In the next episode, we are going to put our hands on writing some real code of our endpoints. All right, then see you in a bit. Bye-bye.